Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, in this video, we're gonna talk about a very important topic these days. We're gonna talk about the electric car. We're gonna show you the main components and the whole process of this new feature or new tactic of designing a car. So let's get started. So here is the electric car. We're gonna talk about this now. So the whole process for main components, we have the main components and the advantages over cars run on gas and the futuristic designs. So here is the main components. The first, suspension system, the chassis, the battery pack, AC motor, AC DC inverter, and the power steering system. For the suspension system, so the suspension is the system of tires, tire air, springs, shock absorbers, and linkages that connect a vehicle to its wheel and allow relative motion between them. Suspension systems must support both road holding, handling, and ride quality, which are at odds with each other. The tuning of suspensions involves finding the right compromise. It is important for the suspension to keep the road wheel in contact with the road surface as much as possible, because all the road or ground forces acting on the vehicle do so through the contact patches of the tires. The suspension also protects the vehicle itself and any cargo or luggage from damage in rear. The design of front and rear suspension of a car may be different. So here we have an air suspension system CAD model using Autodesk Inventor. This is available on GrabCAD website. Just visit GrabCAD website please, and you're gonna find the library, and you can search for any CAD model you want. Okay, you will find some detailed models, and you're gonna find some just step files or any other format. Okay, in the next videos we're gonna talk about the details of the suspension system. We're gonna see each component's function, and we're gonna talk about the more details about that. Here is the chassis. So a chassis is the framework of an artificial object which supports the object in its construction and use. An example of a chassis is a vehicle frame, the under part of a motor vehicle on which the body is mounted. If the running gear such as wheels and transmission and sometimes even a driver's seat are included, then the assembly is described as a rolling chassis. We have here a model that I created myself. Here is the car's chassis. Very simple to do this using the videos on YouTube or any website. You'll just try to find the guidelines and the process of doing this kind of models, and you will get good results by practicing. Okay, but this is the outer frame. We have here the internal frame. I call this the skin of the car, and here is the inside or internal parts. So the car's chassis, can find this on the only body, and here we can see the shock absorbers or the shock if you wanna avoid the front shock for the car, and here is the side one, and there are many details. Actually, we're gonna cover them later. So here the battery pack. So the battery pack is the source of electricity inside the EV. Its capacity and design vary from a company to another. We have here Chevy Bolt EV battery pack. So we have here specs of batteries of different electric car designs. We have here the range 0 to 60 mile per hour. We have here over 200 miles, 237, and so on. We have here the top speed. We have here Mercedes-Benz EQC, and we have here the top speed and battery 80 kilowatt hour. We have here Tesla 75, and we have here the weight and many things, and we have here the prices also, so we can get this table online. We have here the battery pack of Mercedes EQC. It's very unique, and these are a thing that is with the cooling system. You can check on YouTube the video about a first look inside Mercedes EQC. It's pretty cool. Now for the AC induction motor. An induction motor or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. An induction motor's rotor can be either wound type or squirrel cage type. Three-phase squirrel cage induction motors are widely used as industrial drives because they are self-starting, reliable, and economical. Single-phase induction motors are used extensively for smaller loads such as household appliances like fans. Although traditionally used in fixed-speed service, induction motors are increasingly being used with variable frequency drives (VFDs) in variable speed service. We have here the induction motor of Jaguar electric car. It's amazing and pretty cool. We have here the front motor, and we have here the rear motor. Some electric cars or some companies put two motors. One is the main and the other is the standby, like Mercedes EQC. Okay, and we have here the battery, and we have here the suspension system. We have here the shock absorbers, cross springs, and the other components. The AC/DC inverter. So EVs are like an automatic car. They have a forward and reverse mode. When you place the vehicle in gear and press the accelerator pedal, these things happen. Power is converted from the DC battery to AC for the electric motor. The accelerator pedal sends a signal to the controller which adjusts the vehicle speed by changing the frequency of the AC power from the inverter to the motor. The motor connects and turns the wheels through a cog. When the brakes are pressed on the car is decelerating, the motor becomes an alternator and produces power, which is sent back to the battery. This kind of thing is called the regenerative brake. So we're gonna cover that also later. AC stands for alternating current. In AC, the current changes direction at a determined frequency, like the pendulum on a clock. DC stands for direct current. In DC, the current flows in one direction only, from positive to negative. An inverter is a device that converts DC power to the AC power used in an electric vehicle motor. The inverter can change the speed at which the motor rotates by adjusting the frequency of the alternating current. It can also increase or decrease the power or torque of the motor by adjusting the amplitude of the signal. You can find more details from this website. Battery technology has improved hugely in recent years, so current EV batteries are lithium based. These have a very low rate of discharge. This means an EV should not lose charge if it is not driven for a few days or even weeks. The battery charger converts the AC power available in our electricity network to DC power stored in a battery. It controls the voltage level of the battery cells by adjusting the rate of charge. It will also monitor the cell temperatures and control the charge to help keep the battery healthy. The controller is like the brain of a vehicle, managing all of its parameters. It controls the rate of charge using information from the battery. It also translates pressure on the accelerator pedal to adjust speed in the motor inverter. A charging cable for standard charging is supplied with and stored in the vehicle. It is used for charging at home or at the standard public charge points. A fast charge point will have its own cable. Now we are gonna talk about the power steering system. We have here the electric power steering systems are nowadays becoming very popular and attractive for a wide range of vehicles. One of the past decade, EBS type of steering system were targeted to small segment cars. Today, finding an EPS on a premium car is becoming more and more frequent, placing it as a direct replacement for hydraulic actuated servo steering systems. Being the steering system a means of communication between the vehicle and the driver, and the main line where the information of the state of the car and the road inputs streams into the driver perception, the design and testing of such components is playing an important role in the vehicle development process. So as we can see here is the steering wheel. We have here the upper column and servo gear. We have here also the intermediate shaft and the hog joints. And we have here the tie rod, also pinion and rack and pinion, the steering shaft. And we have here the tie rod, the other tie rod. Also, if you wanna use the automatic type, you have to use the motor. Okay, check please the video on YouTube about the steering system or power steering. You will find the difference between the manual and the automatic. The automatic, as like I said, uses the motor, and it helps the driver more and more accurate. We're gonna also, the next couple of videos, we're gonna see in details how we can assemble these parts in details and so on. Steering system main scope is to deliver the directional control in the movement of the vehicle accordingly to the driver input by converting the rotary movement of the steering wheel into rotation of the front wheels about the steering axis. The main requirements it should fulfill are being accurate and easy to handle, requiring a minimum effort to be operated, providing directional stability to the vehicle, providing a proper feedback of the vehicle state and road conditions, isolating the driver from shocks coming from the road, including an energetically efficient servo system. The main criticisms moved to EPS system were that they had a poor feel, were difficult to tune, and lacking in performance were compared to their hydraulic counterpart. But now, with the availability of more advanced systems, things are quickly changing. As a result, not only the hardware requirements, but also functional ones concerning performance of EPS in conjunction with vehicle level of control and feeling are increasing. So we have here the next point in this video, the advantages over cars run on gas. Why do I have to choose the electric car over the gas? So regardless of the type of vehicle you are looking to purchase, there are several costs associated with our car ownership. Choosing an EV over a conventional internal combustion engine ICE vehicle can result in significant long-term savings. If you are considering purchasing a new car and are also looking at an electric vehicle as a serious option, it is important to understand where your costs will come from, and how an electric vehicle can lead to different sources of spending and saving when compared to conventional ICEs. An immediately apparent difference between EVs and ICEs is their fuel source, and consequently what you as a consumer use to power your vehicle. ICEs run on gasoline is burned internally to power the car, while EVs run on electricity. Electricity can come from many sources. many sources, including from the burning of coal or gas or from renewable sources such as solar, wind, and hydropower. The fuel used to power your car is only one factor in the cost of car ownership. In particular, vehicle maintenance costs can stack up over time. With ICEs, engine maintenance can be a huge money sink, especially as cars age. Changing the engine oil, coolant, transmission fluid, and belts can add up in value over time. By comparison, electric cars do not have internal combustion engines, so these costs disappear. Universal vehicle expenses like tire and brake changes, insurance, and structural repair are part of owning any vehicle. But EV owners avoid many of the repeated costs associated with combustion engine upkeep. EVs are not without expenses. However, the largest possible maintenance expense for an electric vehicle is a replacement battery pack, like changing the battery of your mobile or your phone. Unlike a conventional battery, EVs have large, complex, rechargeable batteries that are drained and recharged constantly, which leads to degradation and range loss over time. In the rare case that your EV battery is defective and needs replacement, manufacturers will often cover that replacement with a battery warranty. However, if your car is not under warranty, replacing your EV battery is an expensive bill. The vast majority of EV owners will not have to replace their car's battery, but it's a risk you run when operating an electric car. Why? Because it is a huge battery, not like your phone. A great reason to go with an electric vehicle is the wealth of federal and state incentives available. These rebates help offset the typically higher cost of an electric car to make going electric more financially feasible. Rebates and incentives for EVs are changing constantly, and it is important to know what kind of incentives are available near you. You can learn more about federal and state EV incentives in Energy Sage's Guide to Electric Car Tax Credits. The availability of incentives for buying electric vehicles, coupled with their continuously falling costs, has made an investment in an EV a smart energy and money decision. Electric vehicles are not for every lifestyle, but when compared to the myriad costs surrounding ICE purchase and maintenance, choosing an EV can be the intelligent fiscal decision. We can also find more information about that in this website. So the futuristic designs, we have here the supercharger, the low drag coefficient chassis, autopilot, LED lighting. We're gonna see these kind of things the next videos, and I wish this video gives you a brief understanding of the differences between the EVs and the ICEs vehicles. The next video we're gonna talk about the details of the suspension system and how it works and what are the differences between this suspension and the suspension and what are the functions of each component. Okay, thank you very much, ladies and gentlemen. Wassalamu alaikum warahmatullahi ta'ala wabarakatuh.